Today we're opening up a stack of documentation that gives us a look at, well, the real bleeding edge of ERP customization.
Pretty exciting stuff.
Yeah, we're talking about visual workflow automation and advanced AI that operates right inside the Odoo framework. You shared sources on something called N2,
Right.
and it's described as this framework that makes, previously complex code-heavy features accessible. Things like data-aware AI assistants, internal forecasting tools, all with a low-code visual approach.
It's really the next logical step. I
Uh,
mean, it's about trying to make Odoo deeply customizable without sinking months or even years into traditional Python and XML development.
Think of it as unifying that whole customization layer.
Exactly. So our mission today is to uncover how this node-based system actually pulls off such sophisticated functionality. We want to understand the core architecture,
Yep.
and I think most importantly, pinpoint the real value it brings to a business.
Right. The value in escaping that endless cycle of dependency on specialized and often, outdated third-party modules.
That's the one. So to set the stage, N2 is fundamentally the successor to the earlier Nuido ecosystem. That transition was key. It went from a bunch of loosely related tools to a single cohesive framework.
Okay.
And it's built on two foundational layers. First, you have the N2 backend. That's where all the heavy lifting happens, the Python logic, the execution engine. Then there's the N2 UI front end, which is a dedicated JavaScript framework that powers the visual editor itself.
And keeping those separate is important.
Oh, absolutely.
Hmm.
It's what ensures the editor is fast and modular.
Okay. Let's unpack that architecture, because before we get to the really cool AI stuff, we have to understand the nuts and bolts. If I'm looking at this visual campus, what's the fundamental idea driving N2? How does it turn a bunch of connected shapes into a working process?
The philosophy behind it is actually simple, but really powerful. It's every node is a process. When you zoom out, a whole automation task is just a graph.
The graph.
Right, composed of nodes, which are your individual actions or steps and edges, the lines connecting them, which define the sequence and how data flows.
So the nodes are the actions, the verbs, and the edges are the connective tissue showing the sequence and, I guess, the dependency.
Precisely. And to get a bit more granular, each node has a defined type and a configuration. Their interaction hinges entirely on ports. You've got your standard input and output ports for the main execution flow. Think of that as the sequential highway for your workflow.
Okay, straightforward enough.
But, and this is important, there are also specialized auxiliary input and output ports.
Tell me more about those. Why do you need two different types? Isn't that just adding complexity?
It seems like it, but it's actually adding specificity to reduce visual complexity in the long run. Standard ports handle the flow. A runs, then B, then C. Auxiliary ports, on the other hand, are dedicated pathways for external data that doesn't need to block the main execution.
Ah, I see. So it's about separating the flow logic from the specific data being fed in. That's essential when these graphs get big.
Exactly. You might use an auxiliary input to get a configuration dictionary from a separate settings node, keeping that data off the main graph line and making the primary flow much cleaner.
Makes sense. How does execution actually start?
It's always initiated at a single start node. That node initializes a dynamic context dictionary. That's the central vehicle for all the data transfer. Then the execution just proceeds along the connected nodes from there.
Let's ground that in a simple example. If the context dictionary is the vehicle, how do we get information into that vehicle from the outside world?
Okay, so let's look at the most basic tutorial. Just connecting a start node to a notify node.
Which just displays a message to the user?
Right. You can set it to display static text, hello world, which just proves the connection works.
But the real power, the whole reason we use automation, is dynamic data.
Exactly. So to inject dynamic data, you open the start node's parameters field and define a dictionary. Maybe something like, my message, hello from N2. The start node injects this as start params into that workflow context.
And the notify node downstream just picks it up from there.
Correct. It doesn't need to know the source. It just accesses the context dictionary. Its template can reference that parameter with an expression like start params, my message.
Yeah.
And that proves the whole flow works.
Okay, so that transition from a manual run to a truly event-driven system, that's what makes an ERP automated. How does N2 make that leap from me clicking a run button to the system automatically responding to a change in the database?
That's where trigger nodes become essential. They're designed to listen for external events and automatically kick off a workflow. For example, the onCreate trigger node, it's just constantly monitoring the database. When, say, a new contact record is created, that node fires.
And what context does that event provide that a manual run wouldn't?
It immediately passes the active record into the workflow context. That active record is the new contact record itself. So downstream nodes can instantly grab the contact's ID or name or phone number and do something with it.
Like send a welcome email.
Exactly. That's the difference between a standalone script and a true event-driven automation.
I notice a very specific structural thing here in the docs. They point out that trigger nodes have an output port with a dedicated spec, a special visual shape, that forces it to connect only to a start node. Why that strict rule?
That constraint is all about workflow integrity. The system needs to know that the output of a trigger can only begin a process flow. It's a mechanism to prevent logic errors, where someone might try to connect an external event right into the middle of a process, which could just corrupt the entire context. It guarantees sequencing.
Got it. So that covers responding to events, but customizing an ERP is also about making the system do things, customizing forms, adding buttons. This is where the complexity usually hits. How does N2 handle that without writing XML and Python server actions by hand?
That's the whole purpose of the N2 action module. It gives you a visual, low-code interface to modify Odoo's core behavior.
Okay, let's take a practical example. Say we need a server action that logs some data, and then we need a workflow that triggers when that specific action runs. How would you chain that with nodes?
You'd use a code server action starter node. And remember, starter nodes are configuration nodes. They only run during Odoo initialization to set things up. In that node, you'd paste a simple Python log command, like log, audit message from N2, and give it a unique name.
Like action audit message.
Perfect. Then, in a separate graph, you define your follow-up logic. You'd start with an on-action trigger node, and you'd tell it to listen specifically for action audit message. When someone runs that action, the trigger fires, and you can follow up with a notify node or, kick off a whole approval process.
That's the workflow plumbing. But what about the UI? That's usually the headache. Can you use N2 to just add a custom button to a form view like the contact record without touching XML?
Absolutely. This shows the shift of power. You connect a start node to a view header starter node, specify the target view rest.partner.form, then you chain a form action button starter node. You set the caption to maybe log message and link its action to the server action we just defined.
To action audit message.
Right. And now, clicking that custom button executes our server action and triggers our notification workflow, all defined visually.
That's a huge win for a functional consultant who isn't a Python developer. I mean, they can manage significant UI and process changes without waiting on a back-end dev for every little thing.
It really is. It democratizes these complex features.
Okay, let's pivot to the heavy hitters. We've seen N2 handle data flow and events, but the architecture really shines when we look at how it integrates something messy and unpredictable, large language models. How do you make AI accessible inside an ERP?
It starts by making sure the models are properly registered in Odoo. You use the exact name listed in your AI backend. The basic interaction then involves two main nodes. First, the A agent node.
That's the one that builds the prompt.
Correct. It's the brain that prepares the query. It evaluates a template, pulling in context data like start params, user query, and it produces the final prompt string.
So it's all about prompt engineering based on the context.
Right. That final string is then passed to the A client node. The client node is the one that actually sends the prompt to the LLM, handles all the API communication, and then it exposes the model's complete response as a result parameter for the next nodes to process.
That's the mechanism for basic text generation. But the killer app here is building a smart assistant without coding. And that needs more than just calling an API. It has to know about specific non-public company data.
And this is where retrieval augmented generation, or ORA, becomes essential. A traditional chatbot just relies on its general memory, which, often leads to hallucination.
Plausible, but wrong.
Exactly. RA is like giving the chatbot an open book exam. It forces the AI to ground its answers in your real business data stored right there in Odoo. The accuracy just skyrockets.
But RA is notoriously complex to set up. What's the low-code magic here that simplifies it?
It's the configuration of these specialized, pre-built nodes that just abstract away all the complexity of vector databases and embedding math. You configure nodes like create memory node to index your data, embedding function node to convert text to vectors, and search memory tool node to search over those vectors.
And the data integration itself, how does it pull in the Odoo fields?
That's handled by the AI data tool node. This node dynamically retrieves additional Odoo fields, like a product's price or description, only when the ORG search indicates they're relevant.
Okay, so walk us through that flow. I want a smart assistant for my sales team to query product knowledge.
First, Specific Odoo records, product ID, name, internal description are selected, indexed, and stored as vector memory. When a sales rep asks a question, the assistant uses the search memory tool node to semantically search that memory. It finds the most relevant snippets.
And passes those snippets in the original question to the LLM.
Exactly. So the LLM is constrained by the real data you just gave it, ensuring you get a factually accurate response without exposing sensitive internal data.
That's a powerful standardization of a very complex process. Now, beyond conversational AI, the framework also has nodes for statistical power. What about forecasting?
Yeah, N2 integrates the open source stats forecast library, which makes time series forecasting accessible visually. You'd use a browse date node to fetch historical data like all your sales orders and combine it with a forecast date node.
What's the crucial step for the user here?
The field mapping, that's the key. Statistical models need specific inputs. So you have to map your Odoo fields, like date order, to the statistical fields for date series, and map the value you want to predict, say amount total to amount.
And once the data is mapped,
You can visually chain different training models,
yeah,
a simple historic average node or a more complex auto-ets node. You just set the parameters, like the horizon, how many days out you want to predict, and maybe a season length. The whole thing is configured visually.
So after diving deep into all these technical capabilities, what's the bottom line? For a business already on Odoo, what's the ultimate value here beyond just being a neat technical toy?
I think N2's main value is financial and strategic. It balances developer control with end-user flexibility, and that leads to a massive long-term reduction in customization costs.
How significant a cost difference are we talking?
Very. Many of these features, automation triggers, AI tools, forecasting, are typically sold as individual modules on the Odoo App Store. These can cost anywhere from $50 to, well, over $450 per Odoo version.
And you have to repurchase them when you upgrade.
Every time. N2 consolidates these advanced capabilities natively within the core framework. You're paying for one extensible platform, not 15 separate, potentially conflicting modules.
And critically, it's fully native to Odoo, right? It's not relying on some external platform like which eliminates another subscription fee and another point of failure.
Precisely. The visual designer and the execution logic are all built using standard Odoo components.
Now, a graph of nodes can get complex really fast, sometimes masking the very logic it's supposed to simplify. How does the framework help you debug when a flow inevitably breaks?
It has a really powerful process monitoring feature for that. It's important to note it's disabled by default because it does add some execution overhead.
So you wouldn't want it on in production?
Not for a frequently running process, no. But when you enable it for testing, it gives you real-time visual feedback right on the canvas. As the workflow runs, nodes get highlighted. A yellow border means it's processing.
And green means success.
Green is success. And crucially, a red border instantly highlights the exact node where an error happened. You can trace the error immediately without digging through giant log files. You just have to set the system parameter n2.monitor process to try it.
True. That's incredibly useful.
Ultimately, N2 grants you the ability to build these sophisticated context-aware systems, from multi-level approvals to RG assistance using visual tools that natively understand your business data. Knowledge is most valuable when it's understood and applied, and this just simplifies the application process so much.
And as we wrap up, we have to look at this critical detail from your source material. N2 is currently described as experimental, intended only for testing. The reasoning is to protect end users from deploying mission-critical logic onto a framework that's still evolving. And this raises, I think, a really important question.
Okay.
If this low-code, cost-saving approach to advanced ERP customization integrating cutting-edge AI and statistical tools is already technically viable but is still held back as experimental, what does the future of core ERP software look like once these tools mature and become the standard for production systems, instead of just being novel add-ons? That's something for you to mull over as you explore the next generation of automation.